Students, I'm Alva, and this is our question, and let's solve together. Let's try to approach the answer. Let's try to get the answer of all the questions that we are going through the whole video. Okay, so let's start now. A band in a level road has a radius of 100 meter. Look, this is a band and leveled road. Okay, first of all, let's draw the figure first. This is a band road and a leveled road. Leveled road means there is no theta. It means this road is not banked and has a radius of 100 meter. Okay. Find maximum speed which a car turning. You want to find the maximum speed. It means solution. You have to find V max. Okay. Find maximum speed which a car turning this band may have without skidding. It means you want to find maximum. Look friends, students, look, if you want to find V maximum, it means you have to take a large radius. Okay, if V is small, V is minimum, it means radius is small. Now they have asking about maximum speed, it means maximum radius, and they have given that road is band and has a radius of 100 meter. Radius is 100 meter. You have to find maximum speed, and you want a speed such that the car doesn't skid out. So what does happen? And if coefficient of between tires and the road is 0.8, they have given. Very nice. Now look, this is my car. Okay, this is banding, and let's say we have R is equals to 100 meters. Okay, of course mv square by r must be outward, because you are inside the car, you are watching you are driving a car and you are taking a turn of 100 meter radius. Okay, now this is mv square by r and this is r equals to 100 meter. Now if you want a maximum speed has to be max. If you want a maximum speed, then friction has to be maximum. That is this way, friction will act in this way, that is F max. Okay, so that car will not skid. And this is our normal and this is our mg, which is balancing because this is a leveled road, so no theta is over here. So let's try to find it out. We know that for car not to skid, F maximum should be greater than or is equals to m v max square upon r, right? For car not to skid. Now look, if F is maximum, it means what? F max means F limiting. F value of friction maximum is F limiting, which is greater than or is equals to mv max square by r. But F limiting, we have F limiting is equals to mu into n. This is the value of F limiting, which is equals to mu into mg, that is mu mg, which is greater than or is equals to mv max square by r, or m to m cancel out, and we will have v max square is less than or equals to mu g r. I hope you understand mu g into r, and v max is less than this. Let's put all the values. That is V max square is less than or equals to 0.8, the value of coefficient of friction given here, into 10 into R is 100. Okay, fine. If I cut this to this, since this is a square, so I have to find the square root over here. So 0 to 0 cancel, decimal to 0 cancel, and I will left with 800. So I will left with some roots value. So friends, what students, look here, we can do one thing over here. Let's replace this 10, g is equals to 10 by 9.8. Okay, why I'm doing this? Because if I cut from this decimal will be cut it out, and 98 into 8 will be there, which gives me value of V. Let's convert this less than sign equal to sign, and I left with 784. Sorry, this point and this point, this two decimal will be cut by 100. Okay, and I left with V 784, and 784 is a square root of 28. You can do it 28 into 28, you will left with 784. Okay, so V max is equals to 28 meter per second. So this is your answer. Okay, now next question. An aircraft executes a horizontal loop at a speed of 720 km per hour with its wings banked. Now this is the banked question. Okay, banked at 15 degree. What is the radius of the loop? Now they have asked about radius. Okay, so first let's draw the figure and try to get some insight with the figure what they have been asking. This is my solution. Okay, so let's say we have a banked road. And this is like this. This is a banked road, and aeroplane is traveling like this with a wing 15 degree. Then here theta is equals to 15 degree they have given us, and the plane is flying like this. Fine, no issues. So let's draw our cross-sectional area over here and get a better picture about it, so that we'll get a component and just to have a better feeling. Okay, then theta is equals to 15 degree. Fine. Okay, now this is my plane. Plane is flying like this. Okay, now give me some other color pen. Look, this is my normal. This is my normal. This is my mg component, and with the same height I got this angle, and since this is theta, so this is n cos theta, and this would be my n sin theta, and this would be mv square by r. Okay, fine. Here students, here theta is 15 degrees, so I'll just, when I will start my calculation, I'll put it there. So this is the whole picture. Here's my plane, this is my n, this is my mg, n cos theta, n sin theta, and why this is theta. I have covered all the topics and derivations in my previous video, so please do watch and don't forget to like, subscribe and share. Thank you. Now look, n sin 15 is equals to mv square by r. Fine. And n cos 15 is equals to mg. Let's say this is equation 1, and let's say this is equation 2. One more thing is v is equals to 72 km per hour. So for standard speed, that is to convert it into meter per second, we have to multiply it by 5 by 18. So just left with sorry, it is 720, not 72. This is 720. Okay, 1840s are, so we have 200 meter per second. Okay, so we have 200 meter per second. So okay, fine. Now let's divide 1 divided by 2. So we get n sin 15 upon n cos 15 is equals to mv square by r divided by mg. So m to m cancel, and this to cancel, so we have I love, and all the things cancels out. V square upon rg. Okay, So remember, these expressions we already dealt with in our previous videos. So fine, this is our values. We have the value of V, we have the value of G, so we can find R. So let's try to find out. Students, one thing, it's not given in the question what is value of tan 15. So let's try to find out the value of tan 15. You know the formula, tan A minus B is equals to tan A minus tan B divided by 1 plus tan A into tan B. Okay, so tan 15 can be written as tan 45 minus 30 degree. So you will get 15, which is equals to tan 45 minus tan 30 divided by 1 plus tan 45 tan 30, that will be equals to 1 upon under root 3, 1 plus 1 upon under root 3, which is equals to root 3. Here LCM, root 3 minus 1, root 3 plus 1, and root 3 cancel out. So you are left with this figure, okay, this value. So what you can do now, either you take it as a square, so root 3 minus 1, so that it will be minus that root 3 minus 1, okay, or roots, this is minus then plus, minus, okay, fine. So let's directly put the value of 1.73 under root value upon 1.73 plus 1, that is equals to 0.73 divided by 2.73. Okay, so when you divide the both, you will get an answer. I think if you divide 2.73, so it will go by 2s. If you put 0 here and 2 2s, that is 20, you will left with 273. No? 273 2s 546. Okay, fine. So you will have the answer 0.26. Okay, you can divide it. Now you have the value of tan 15, that is tan 15. This is tan 15, which is equals to all these things. Okay, fine. Now we have the expression tan 15, so we can write directly 0.26 is equals to V square R into G. Let's say G10. So 0.26 into 10 is equals to, what is the value of V? V was 200. So 200 square upon R. Fine. So this would be 2.6 is equals to 2 2s are 4. Let's say 200 into 200 divided by R, or R is equals to 200 into 200 divided by 2.6. So I can easily do one thing, that is 10 to the power 4 I got. Okay, fine. So 10 to the power 4, that is 4 into 10 to the power 4 divided by 2.6, which I get a value of 1.4 into 10 to the power 4 meters. So this is the radius. So can you imagine, when you have a speed of 200 meter per second in speedometer, just look out, watch out the speed of 200 meter per second. When you go with such a high speed on a bank road, which is just 15 degree, very less 15 degree angle, and 200 meter per second over there, so you need a radius which is equals to you have a radius equals to 10 to the power 4, that is 10,000 meters, center point to 10,000 meter. So just a speed of 2 with such a high turn, you need such a high radius. So quite a big question. A car is speeding on a horizontal road. This is a horizontal road. Very good. Curving round with a horizontal road, it means we can have a picture like this. This is our road, and since curving round with a radius of, what is the radius? 60 meter, and curving around with a radius of 60 meter. The coefficient of friction between wheels and road is this. The height of the center of gravity of the car from the road level is this, and the distance between the wheels. Calculate the max safe speed for negotiating a curve means, if you want to deal with this curve, then you need to find certain velocity, then you find maximum. They have asked about maximum speed. It means you have to find the maximum friction, because maximum friction can only maximum friction can prevent maximum speed. Okay, so car will not skid if you have a maximum friction. Fine. Will car skid or topple if this velocity exceed? Okay, so they have asked two questions, toppling as well as what can we say, negotiator, toppling or sliding, skidding, of course. So we have to find two things here. Okay, car will skid first or car will topple first. So in my previous video, I have given a detailed information about toppling conditions and when toppling will occur and how to prevent toppling, what are the conditions of toppling. So all things we had deal with in that video. So let's start the question here. This is my car. Okay, they are saying the height on the car round the radius. Okay, the radius is 60 meter. Fine. Now what informations we have? Mu. They have given us mu is equals to 0.5. Fine. And the height from the, and they have given height also. The height of the center of gravity. This is mg. Okay, this is center of gravity, mg. Then the height is 0.3 and the distance between the wheel is this. Look, I'll just draw a proper diagram of it, so that only with this car now, so that you will get a better understanding. This is our normal, this is our mv square by r, and of course we have a friction over here. Okay, so students, look. Okay, when we discuss the condition of toppling, then we will take 0.3 and 0.8. Okay, right now we just find the skidding velocity. Okay, Vmax we will find out. So to find Vmax, what we need, this is our car. Okay, from this picture you get a better idea, na? So just solve it. So we want Fmax should be greater than or is equals to mVmax by r. This is our condition, not to skid. Not to skid. Fine. Now Fmax is equals to F limiting, because maximum friction is limiting friction, that is greater than or is equals to mVmax square by r. Okay, fine. But F limit is equals to, what is the value of F limit? F limit is equals to mu into n. And what is the value of n is equals to mg. So mu m and g, mu m and g. Okay, so directly over here, so mu m g must be greater than or is equals to mv max square. This is mv max square by r. Okay, now m to m cancel. We have mu g r is greater than or is equals to v max square, or V max is less than or is equals to mu g r square. Fine. Just we convert to equal to sign so that it looks nice. Fine. We have mu in the question. Mu is equals to 0.5. We have g in the question. Let's say g is 10, and we have r in the question, that is 60 meter radius. So this to this cancels out. We have 60. V max is equals to 6g, or V max is equals to under root of 6g meter per second. Fine, all good till now. So this is the speed. Okay, fine. So point, oh sorry, here I have done mistake. This must be 300, because point to point cancel, and 5 6 are 30, so it's 300. So better 3 into 100. So 100 square root was 10. So we can take out 10 and we are left with 3. So it must be 1.73 into 10, which is equals to 17.3 meter per second. Okay, till now everything is fine. So we have maximum speed is equals to this. This is the maximum safe speed. If you go beyond this, then your car will skid. And limiting friction, because maximum to maximum friction is F limiting. This is F limiting, which is maximum to maximum friction a road and a tire can provide. And this is the maximum safe speed turn you can take. But if you exceed beyond that, then even friction doesn't have value more than this, so your car will skid out. Okay, so we have drive a maximum safe velocity. Now in the question they have asked, will toppling if this velocity exceeded. If this velocity exceeds, what is the value of the toppling velocity for toppling? How much velocity should be there so that the car will topple? So let's discuss this case also. So look here, I'll just draw a car right now. This is my wheels, okay, and we have mv square by r. So mv square by r in this direction, fine, and this is max speed. I just write v max because we have calculated maximum speed. Okay, now from what in the question they have given, the height of the center of gravity of the car from the road level is 0.3. It means the height, this is the center of gravity where we have mg downwards. Okay, so the height from here, height is, that is from the ground, car is on the ground, of course. This is, so height is, this is the height, which is equals to 0.3 meters. Fine. Now I just want another pen. And the distance between the wheel, they have given the distance. Calculate from the road the level, and the distance between the wheel is 0.8 meter. So this is 0.8 meters. Can you see? This is 0.8 meters. This is mg, this is mv square by r. So students, what you have to do, the condition you have to apply the toppling condition, that the maximum value of v, you have to find the maximum value of the v so that the car will not topple. If this mv square by r is much greater, then this is the, you can imagine this is the pivot point of the car. This is the pivot point, and car will topple in mv square by r direction. So we have two forces, mg is a force and mv square by r is a force. So what they are doing, mv square by r wants to topple the car in clockwise direction, that is in this direction, and this mg wants this is clockwise and this is, and this mg, if your car will be like this, then mg will let it come down. Again it will be anti-clockwise direction. So mg is counter force and this is clockwise, this is countering this force. Okay, so what we will do, that torque, this is the pivot point, this is the pivot point. Okay, so what we will do, this is our 0.8, so half of 0.8 is, this is center of mass, since name is center, so this must be the from the pivot point, this distance, this is the perpendicular distance of mg. What is this? That is 0.4, right? 0.4, and this mv square, it has the perpendicular distance 0.3. So for we will find out the condition when the car will not topple. Just condition. We will find just condition of car not to topple. And if we find this condition, this velocity, it means if you give a slight more velocity beyond that, the car will topple. The car will start to topple. Okay, so this is the force. If you take one is clock plus sign, then other one is minus sign. So what I'm going to do, I'm just equating both. That is mv square, mv max square by r, okay, must be equals to mg into, oh sorry, this is h, okay, so I just write it down, mv square by r into h. This is the force, this is the centripetal force, and this is the perpendicular distance, and this is mg is a perpendicular distance 0.4. okay, fine. This m to m cancels out, or we have v max square into h divided by r is equals to g into 0.4, or v max square is equals to 10 into 0.4 into r divided by h. Since r is 60 into 10 into 0.4 divided by h, which is 0.3, that is v max. Maximum to maximum velocity when car will topple. Okay, so this is the just toppling condition, and before this, if you give more than this velocity, the car will start to topple. Okay, so this point and this will cancel out. Okay, and if you just take 0 over here, this decimal and 0 there, so 4 6 are 24, and both the zeros over there divided by 3, that is 3 8s are fine. 3 8s are 24. Students, I can do one more thing. 4 is 4 9s are 36, 37, 38, 39, 40, 41, 40, 43. Yes, I can do one more thing. Just rub it off and just replace v max square is equals to r into, this is 10, just write it down, 9.8 and 0.4 divided by 0.3. okay, this decimal, and let's cut out this decimal. Okay, fine. Then value of r is 60, 60 into 98 into 0.4 divided by 3. Okay, fine. Now r into 9.8, 0.6 divided by 0.3. Now this is the decimal, this cut, and this value cut. 3 1s are 3, 3 2s are 6. Okay, fine. Then we are left with 2 into 98, that is equals to, this is all v max square, which is equals to 2 is a 16, 2 9s 18 or 19, then 196, and the value of 196 is under root 28 meter per second. Okay, if we will take 10, then we have to deal with under root, so I just replace 10 by 9.8. so please don't mind, I don't like this square roots like this, I just want a whole square. So this is the maximum safe speed, if it means, and our that maximum for toppling, this is the condition for toppling. And for skidding we have, value approximately 17 point something, right? 17.3 meter per second. So if you start your car from 0, 1 2 3 4 5 6 7 8 and go till 17, so first your car will skid, and if until you reach the velocity of 28 meter per second, then will start to topple. So first skidding will be, sometimes there will be a question in the exam, so car will slide first or skid first or it will topple first. So of course it will skid or slide first outward, of course. Why? Because this 17.3 comes and 28 is 28 comes later than the 17.3. The car starts from 0. First it will reach this velocity, then it will skid out, and for toppling you need this much amount of velocity. Okay. Students, in the previous question I had just done a mistake here. Just mark it out. This is 2 into 98, 2 into 98, so I forgot 4. So just multiply this 4. I multiplied it by 4 and I got the answer when I multiplied, that is 784. So answer will be 28 meter per second. So please correct it. Okay, now next question is, a car is negotiating a curved road of radius r. The road is banked at an angle theta. The coefficient of friction between tires of car and road is mu as the maximum safe velocity. Okay, a car is negotiating on a curved road and these are the options they have given us. So what information we have? We have radius r, angle theta, and friction is mu. We want maximum safe velocity. So for maximum safe velocity, we need a maximum turn. Okay. So what will happen? Let's draw a figure first. This is an angle theta. Car. This is my car. Okay, fine. This is my car which is moving along this direction, and let's say we have friction over here. Why? Because we are taking maximum velocity. So for maximum velocity you need, suppose the car is moving on this edge of a maximum radius. So if you want maximum radius, if you want maximum velocity, so you will take a quite long radius, a circle of quite long radius. Okay, so it will go like this. So what friction will think? Friction will think if wheels are going in the direction of mv square by r, so friction will be in this direction. Okay, and here will be mv square by r. Okay. Look here, friction mv square by r is not acting on these wheels, it's on center. Okay, you want make me to draw another figure? Okay, fine. This is angle theta. Okay, and here is my wheels, here's my car. Nah, this is fine. This is mv square by r. We just cut it down. Okay, and friction will be along this direction because car is taking maximum velocity, so high radius, so it's that friction will be in this direction. Okay, so just draw it like this, so that taking a cross-sectional area. So this is our theta, this is our cross-sectional area, and here is my car, here is my car, here is my normal, here is my mg, this is my angle theta, and this will be first, let's just draw a component of this figure, and cos theta and sin theta. Fine. And now look here, mv square by r in this direction. This is a banked road. If you just draw a quite like this will be a banked road. Car mv square by r will be in this direction. sorry, it will be like this. mv square by r will be, so center, this is our center, so this is our mv square by r, okay, along the center. This is my friction force. Okay, fine. This is my friction force. Now I want component of friction which is along mv square by r. So I know this is angle theta. Why this is angle theta? Because it's making an alternate interior angle. This is z. Okay, z. Then if this is s, then if this is f cos theta, and this component and this component. So f cos theta, mg, and f sin theta. Okay, so these are two components of this f. So now we just have to make the equation, and then here we go with our solution. Can I write it here? Okay, then we have n cos theta, which is balancing out with mg plus f sin theta. Okay, so what I can do here, I can do one thing, n cos theta minus f sin theta is equals to mg. Fine. One more thing, since we want maximum velocity, it means friction has to be maximum. So this f is equals to f max. This has to be maximum friction, and f friction is nothing but your limiting friction. And what is the value of the limiting friction? It is equals to mu into n. So just putting mu into n in this equation, so we'll left with n cos theta minus mu n sin theta is equals to mg. Okay, so this is my equation 1. Good. Now we are balancing this one. Here is n sin theta plus f cos theta is equals to mv square by r. N sin theta plus f cos theta, n sin theta plus f cos theta is equals to mv square by r. If you want to write here, write maximum velocity. Okay, now this is again f, so f can be replaced with the same reason as I given above, that is n sin theta plus mu n cos theta is equals to mv max square by r. Just multiplying r here, so nr sin theta plus mu n r cos theta is equals to mv max square, and this is my second equation. Okay, now in the options I got a plus sign above. Okay, I got a plus sign above, so this is my minus sign with equation 1, and this is my plus sign in equation 2. So I think I will divide 2 divided by 1. Okay, so what I left with, that is n r sin theta plus mu n r cos theta is equals to mv max square divided by n cos theta minus mu n sin theta mg. So what here is n cancels out. Okay, and here m and m cancels out. M and m cancels out. Okay, since we want to find maximum velocity, and it is, the equation is in terms of theta. Okay, fine. So we just want theta over here, and just take it out r common. First do this thing. If we want theta, so divide this equation by cos theta. So we're left with r tan theta, cos theta if we divide, plus mu r, this is 1, cos theta cancels out, and here 1 minus mu sin theta upon cos theta is tan theta, which is equals to V max square by G. Okay, now you can take r common, and you can multiply it by G. So we are left with tan theta plus mu divided by 1 minus mu tan theta, which is equals to V max square, or V max under root sine, that is under root of Rg tan theta plus mu, Rg tan theta plus mu 1 minus mu tan theta is equals to V max. So this is our maximum velocity in terms of theta, Rg and mu. So let's see what is the correct option. Tan theta plus mu, 1 minus mu tan theta, 1 minus mu tan theta, but r into g, we want r into g. So option A is correct. Correct option. So students, I have made 4 parts of on the topic banking of the road, and in the last part I have solved the questions related to the concepts which I had given earlier, and try to make you understand the concept even with the numericals. So hope you like the video. Please do share, subscribe and like, and don't forget to comment. It will motivate me a lot. Thank you so much.